Okay, this is 7.3, page 2, and there's a lot going on here, but it wants to try to give you sort of a visual example of what we're talking about when we talk about a multiple three variable systems, and we know that if you have x and y with x and y axis, then it can be graphed on a plane. But then when we add that third variable z in, what does that do? And it basically turns it into sort of a three-dimensional plane or we have three planes, and you can kind of see what that looks like, with what happens when we have our x, y, and now we've added a z in there, and then what that looks like with actually three planes. So instead of just having two planes intersecting, now we have three. And so if we look here with our x, y, and z, so we have 3x, that's here x, there, the 4z, okay, it's along the x-axis. And anyway, so it kind of gives you a little bit of an idea. It's a little complicated, but hopefully visually you understand what it says. Now, what we saw when we were solving equations is that if those three planes, and those three planes are created by the three variables, if they all intersect in one point, then that's when we have this unique solution. This unique solution. That's where we have our ordered triple, our x, y, and z. So the three planes intersect at one point, and that point has an x, y, and z value. Now, I think we saw, I can't remember in one of the examples, where there was an infinite number of solutions. And that means we have these three planes, they all intersect, but they intersect in a line, so there are an infinite number of solutions, right? Here I have just one, infinite number. Then if the three planes have no points in common, so like these two planes have a point in common, but this third plane here isn't part of it, or these two have something in common, these two have something in common, but not all three. And in this case, none of them are intersecting at all. So we have, anytime that we have no points in common of all three, then we have the no solution. Okay, so we're going to look at non-square systems where the number of equations is not equal to the number of variables, in which case you can only find a general solution, since it's impossible for two planes to meet at a point, right? If we have two planes, here's a plane, and, it intersects with, this plane here, okay? It can't intersect kind of like over here. Here, three planes, they can intersect at a point. But if you only have two, they can't intersect at a single point. All right, so we have what's called the general solution, which means that our solution is all going to be based on one of the variables. And it could be any one of them, but usually one fits better than others do. All right, so we're going to do same thing we were doing before, though. We have equation 1, equation 2. So I'm going to start out by just adding 1 plus 2. And the reason I'm only having to add 1 plus 2 is because, as we see, we have a plus and minus z here. So we know we're going to get rid of, we can eliminate the z from that. So I have 3x minus 3y equals 3 when we add them together. I'm going to go ahead and divide everything by 3, so I have x minus y equals 1. I'm going to go ahead and solve and just simplify this. X equals y plus 1. So now I have a value for x, but it's in terms of y. But there's my x. Now I'm going to use equation 1, but I'm going to use it with x equals y plus 1. So let's come back to our equation 1, and let's rewrite it so we have y plus 1 instead of x, right, minus 2y plus z equals 2. This would give me negative y plus z equals 1, right? Because I combined my y minus 2y, and then I moved my 1 over here. So if I solve this then for z, I have z equals y plus 1 also. So in this case, I have two of my variables solved in terms of y, which means y is the one that we're going to kind of leave by itself. So as we write it as our triple, it would be y plus 1, because that is our x value. And then it would be y, because in both cases we have both z and x solved in terms of y. So y is by itself, and then we have y plus 1. All right, so it is all of our solutions are three values. They're all going to be in terms of y, and every time they'll all be in terms of one of the variables. It might be x, it might be y, it might be z. That is however it works out. Okay, let's do the same thing over here. Oops, we're going to go 1 and 2. So I'm going to go. Well, you could pick a lot of different options here. I think what I'm going to do is I'm going to do 1 plus 4 times 2. So that way if I come in here, I multiply everything here by 4, right? Then I'm going to get 16x minus 4z equals 0. But I want to be able to get rid of that. So that's what I do. I would go x minus y plus 4z equals 3. And then what I just said, 16x. There is no y value. So it's going to be minus 4z equals 0. That gives me 17x minus y equals 3. So I'm going to solve this for y. So let's see, negative y equals negative 17x plus 3. But I don't want negative y, I need y. So y equals 17x minus 3. Right, which means I now need to use one of my equations. I need to plug this value into y. And oops, why did I keep doing that? Just clean this up so we can see again. Since the second equation has no y, we have to use the first equation. So we're going to come up here and we're going to go x minus, instead of y, we're going to go 17x minus 3 plus 4z equals 3. This is x minus 17x plus 3 plus 4z equals 3. Let's clean that up. Let's see, we have a negative 16x. We're going to subtract 3 from both sides. We're going to leave plus 4z, and that leaves us with 0. Okay, hopefully you got the algebra down. So 4z equals 16x. Divide both sides by 4. Z equals 4x. So now we've solved for z, y, and z in terms of x. So again, when I do my coordinated triple, let me have x. 17x minus 3 represents my y, and 4x. And we talk about a general solution, that's what we mean. So because it's a line, right? There's an infinite number of solutions. So whatever value you put in for 1, you put in 1. And so that would be if x equals 1, it would be 1, 14, and 4, right? If x is 0, it would be -3, right? So all of those points, all of these points would be part of our solution. All right, quick video. We will go to page 3, which is a bunch of problems. So I'll do that in a different video.